Okay, BC, Unit 1, Sum 9, Pretest Graphing Calculator. So, check your answers over here. So, that's all of them. That's all the answers. Pause it if you need to. Okay. So, I'm going to go ahead and do those problems. You do need to sketch graphs, and you need to show me setups sometimes, like for intervals and stuff. So I gotta have a little idea of how you're doing this. So first problem, trying to solve this rational exponential inequality. So we want to move everything to one side, less than 0. That to me is the best strategy. Now, you could graph this graph and this graph and see where this graph is below this graph, which could work, and you should get the same answers, but it's potentially messier. So I like to take this approach. This is easier, less messy. So, should be in ready mode. 2 divided by parentheses, y equals 2 divided by parentheses 1 plus x, you definitely need parentheses, minus e to the 2x close. Okay. And when we graph this, we should get a vertical asymptote at -1 for sure. Okay. And so window, -10 to 10, they're telling us. So I guess we could do -10 to 10. We could do maybe zoom standard. I don't know. But it's just a good starting spot. So there's the vertical asymptote. And then this graph looks like it just goes down over here. So well, it seems like a pretty good graph. So I'm gonna sketch that. Lots of room. And like I said, we should expect there to be a vertical asymptote there. That should help you understand the graph better. And then, it looks like it stays below the x-axis there. That's something that maybe we should confirm. Let our calculator confirm it. But for now, I'll kind of assume that's what's happening. But there's a way to do it. And then here, it looks like it goes, and it maybe crosses the origin. But again, that's something we need to let our calculator confirm for us. You could zoom in, and that would help clarify it, but really in the end, you want to use your calculator to find this. So, my answer is, where is this below? So I'm thinking it's all of this, right? And then I'm thinking there's a solid dot somewhere around here, and it's all of this. So my answer right now, I've pretty much got it. I think it's -10 bracket, comma, to -1 parenthesis, because it's a vertical asymptote, so the graph doesn't actually exist there. Union, bracket, whatever that x-intercept is, to 10. That's my answer. All I got to do is find out one x-intercept. I also probably want to confirm that it doesn't cross over here. So let's try that first. If I say second calc 0, and I'm like, well, let's look for over here. Let's say -10 to -9, guess -9.5. If there's anyone anywhere near there, it's going to find it. Otherwise, if it doesn't find one, I don't know if it'll find this one because of the vertical asymptote. So it says no sign change, error. That just means there is no x-intercept over there. So that helps confirm it. And let's find this one right here. Second calculate 0. It looks like it's at 0. So, we say -1 to 1, guess 0. It is not 0. It's small. So let's write that 0.239300017. So this is the kind of stuff I want to see in here. I want to see a nice graph label, because after that, you're done. That's your answer. round truncated through decimal accuracy. That's it. Okay. All right. And show this too. If this is the way you're doing it, if you made two graphs, then your graph would look different than mine. So this is what I got when I did two graphs. It wasn't too bad this time. It's still harder, but it would give you the same answer. Next one says, find the area of the region enclosed by y1 and y2. This one, we need to graph these separately. We need to get a graph of these. So we're going to go to y equals, and we do math, num, abs, and we're going to do e to the x, close, minus sine x, close the absolute value. The next one's going to be inverse tangent of x plus 2. You should probably be in radian mode unless there's something explicitly telling you to do degrees. Okay, I don't know what the window should look like. Let's just start with negative 10, 10, negative 10, 10. Zoom 6. We'll see what happens. So we got this kind of bouncing graph. And then this other graph that it looks like, it says enclosed between them. So it looks like it might just be this little section right here. But I think we need a better view of what's happening right here. But we could draw a rough sketch right now. So it's kind of like coming in here, kind of bouncing along, and it kind of goes like that. And then this graph is coming in here, and then it looks like maybe it crosses it. And then that would be the area we're looking for. Let's do zoom. I like zoom box for this because it's such a small area, and I can just create a box around it. So here, so that's the first graph. Graphs it first, and here comes the other graph. Yep, that's the region. So we got to find this intercept and this intercept, because our strategy here is we can find the area beneath that graph, right? We can find this area and then subtract this area from it to get that little sliver up there, right? To get this. So the setup I need for this is I need an integral of the graph on the top is this one, absolute value of e to the x minus sine x dx, minus integral of inverse tangent of x plus 2 dx. You need the dx's. And then you're going to be able to write the answer. Now you can calculate this separately. We could do this on the home screen. I'll show you both ways. If you're going to do it from the graph screen, you have to do them separately. But we got to put the limits on here. So we got to find that second calc intersect, first curve, second curve. Your guess will find the one it's closer to. So there it is. And put that on my graph, negative 0.3057735, comma 1.0375843. So doing this will also help me give you partial credit. Let's say you mess it up, but you put this here and then you put the right numbers here based off your mistake, then I'll give you probably more credit. Second calc, intersect, first curve, second curve. This one we could type in maybe 0.5, make it a little quicker. Looks like it's around 0.5. So that is 0.531404006, comma 1.1945751. All right. So for our setup here, for integrals on EC setup, so the limits are going to be in the x direction, left to right. So it's going to be negative 0.305773. I'd carry at least a few extra decimal points beyond 3. If you only give me 3 here, I'm taking points off. because you're jeopardizing the accuracy of your final answer by rounding truncating to what you desire to have in the end, but in the middle of your work. And then this one's 0.5314404. I'm doing 6 decimals. These are the same ones, so you need to write them here also. So I need this to give you credit, even if you get the right answer. Yeah, I don't need to see the buttons you're pushing and stuff like that. This is just helpful for you if you're going to try and figure out your game plan. Now, on here, I can do second calc, number 7, and it's going to do the absolute value curve. And I got to type these in, negative 0.305773 for the lower limit. Upper limit is 0.531404. And, you know, I guess it's kind of cool because it shades it. Oh, I did the wrong one. Okay, that's not the one I thought it was. So I'm going to write that number down. That's clearly the lower one. The lower one was the first one, right? So this should be minus, and this should be plus. So I wrote this wrong. But I figured it out from the picture. I guess that's the one benefit. You know, this is going to be negative 0.873247. That's this one. Okay, so that was the first one. I just kind of in my mind thought, oh, the higher one's the first one, but it's not. And then this is going to be the other one, so I can calculate. Number 7. Now you have to change which graph you're going to integrate. So if we just go with Y1, that's the one we just did. You go up or down on this, and it tells you which one. So that's the one I want. We got to type the limits in. Never just use the cursor to go back and forth. These need to be exact. Negative 0.53, or sorry, negative 0.305773. Enter 0.531404. And then you can kind of see it shades that in and everything else. So this is going to be 0.941447. And so then I can go back to this screen and type these in. 0.941447 minus 0.8732474. Another way that you can know that you did it wrong, like you subtracted the wrong one, is if you get a negative answer. Area is supposed to come out positive. Something's wrong. So final answer is 0.068. That's it. Rounded, truncated, 3 decimal accuracy. That's it. So the other way you could have done this is on the home screen. You could do it here, and you could do it all at once and not have to write down 2 separate numbers and then retype them. You could do math 9 bars, y bars, function. Now we want y2 to be the first one. We already learned that lesson. Comma, x, comma, and then we got to type the negative 0.305773, comma, 0.531404. Okay. Minus math 9 bars, y bars, function, y1, comma, x, comma, negative 0.305773, comma, 0.531404. Same answer, right? You got a little different at the 4th decimal. So now it'd be interesting. I'm not guaranteeing this. If we got rid of any extra decimals in our work, see if it messes up our answers. It's not guaranteed it's gonna mess it up, but let's say we get only 3 decimals in our work. Well, we still would have got the same answer at 3 decimals, but it is different at 4. So if you get lucky, I don't give credit for luck. So I need to see you do it the proper way, even if it doesn't end up making a difference. Now these graphs, this is parametrics, which you don't even need to know. That's 2-dimensional motion. This is velocity being positive velocity, negative velocity. moving to the right, moving down. You don't even need to know all that. You could just be like, oh, this is x. dx dt means a derivative. So that'd be the first thing to do is to find dx dt. And that'd be 1 minus cosine of t. And make it less than 0. Now, this one you could actually do by hand. But let's act like we can't. So what we could do is we could just graph this graph. 1 minus cosine x. Okay, radian mode. And we just want to see where is it above the x-axis. So we're going to go window 0 to 2 pi. And I mean, you think this is a cosine graph that's been shifted. It's been flipped and moved up. By -2 to 3. I mean, if you're not sure, you'd be like -5 to 5 or -10 to 10. It helps if you have a rough idea. So if we graph this is the graph. And I want you to sketch it. So the graph looks like this. 0 to 2 pi. Goes up to 2, right? Now we're saying, where is this graph above the x-axis? Well, or equal to it. It looks like it's the whole time, right? It looks like it's the whole graph. Now let's verify that where those x-intercepts are. Let's not just assume that it's at 0. Maybe it goes below the graph a tiny, tiny bit. Second calc, 0. Let's see if we can find that one. 0 is my left bound, 1 is my right bound. Guess 0.5. Let's force it to look for 1 over there. No sign change, which means maybe it didn't quite get to 0. Let's try the other side. Well, here, I'm going to show you something else. Let's try it again, but let's say second calc 0. And then go 0 to 1, but guess 0. Boom, it found it this time. It's kind of weird. It uses different algorithms. So that is 0, 0. By the way, and I think there should be one over here. Second calc 0. Now we could say 1, 2, 3, 4, 5, 6. We could say 5.5 to 2 pi. Guess 5.5 to 2 pi. Shoot. 2 pi should be like 6 point something. Second calc 0. 1, 2, 3, 4, 5. 5.5 to, see, I want to say 2 pi, and that's, it keeps not letting me do that. Okay, well, this is a little frustrating. You could say it's 3.14, so 6.28. Guess 6. It's probably not going to find anything. It needs to be exactly 2 pi. Anyways, well, this is a special case. But I'll give you one that's a little more odd, that works a little better. Oh, did I? Okay, that's good. All right. So, anyways, the answer is 0 to 2 pi. The other way you could do it is you could go about solving this like you would by hand. And you say, well, when is cosine equal to 1? It's at 0 plus 2 pi k. So 0, 2 pi are your roots, and then you do a line check, and these would be solid dot 0, solid dot 2 pi. It's also the boundaries. And then you could test a value. You could test pi. And cosine of pi is -1, which is true. And this is that special case where it's problem child or bounces off the graph. So it's the same thing. But anyways, on the test, I'm going to give you one that you can't do by hand. So now this one right here, dy dt equals -2 sine t less than or equals 0. So you graph that, -2 sine x, and window, should be fine. So it's just it's an upside down sine curve, amplitude multiplied by 2. So you would sketch this if you're using calculator, which on the test you're for sure going to want to do, even though you could do this one by hand also. So now we're saying, where is it below or equal to 0? So I'd say solid dots, and this is the chunk of the graph. So second calc, 0. Looks like there's one over here at 0, 0 to 1, guess 0, 0, 0. Write that down. Second calc, tray 0. Let's find this one around 3, like 2.5 to 3.5, guess 3. 3.1415927. Does that number look somewhat familiar? Pi. I mean, you could find out what's going on over here. So I can calculate 0. Now, we ran into trouble last time. 5.5 to 2 pi. Didn't like us putting 2 pi in. I don't know why. I mean, if you do... Let's try it. I'm going to try and trick it. 5.5 to 2 pi minus 0.000001. I'm going to make it really close to 2 pi. It's okay with that. And I'm going to guess like 6. It's not going to find one, which is going to confirm. I don't know. So, anyways. But that's an answer right there, right? It's a solid dot. That's one of those. So the answer is 0 to pi, comma, union 2 pi. Now, if you did these with a line check, you'd say, okay, well, when does sine, you'd flip it around if you divide it by -2. Isolate the trig, and you say, well, when is sine equal 0? 0 plus pi k, so 0 pi, 2 pi. That confirms that, yes, there is an intercept there. Line check. These are going to be solid dots. 0 pi, 2 pi. And test a value, pi over 2. Which is 1, which is positive, which is true, false, true, false. And so you get the same answer. But on the test, I'm going to actually give you something that you can't work out by hand, just to make you do it on your calculator. So, but some of the weird issues here, I don't think will be issues then. Okay. Find the equation of the tangent line to the graph. So let's graph this. You get away without graphing on this one, I guess, depending on how you do it. But one way to do it is to graph it, which might just give you a basic idea. Window. So I think we're going to do zoom 6, -10 to 10, see what happens. It's kind of cruising and then blows up. It's kind of interesting. Looks like a sine curve and then blows up, which kind of makes sense because when x is negative, e to the x is like small. So the graph just behaves like a normal sine curve for negative x values. And then as soon as x gets positive, e to the x blows up. So it makes sense that it kind of takes over the graph. So x equals 1 is, I don't know, somewhere around here. We could sketch our tangent line in. We're trying to find the equation of that. So we need two things to write the equation of any line, a point and a slope. So the point, we just plug one in here. And That's your point. It's sine of 1 plus e. That's the y value. This is the x value. Now, I don't know. We could go and get decimals for this if you want. So, or you could, on here, you could say second calc value, x equals 1. And it gives you 3.5597528. Okay? So that's your point. We need the slope. So we can do that from here. We can say second calc dy dx and say x equals 1. You get 3.2585845. So then we could write the equation right now. Point slope form, y minus 3.559 equals the slope 3.258 comma x minus 1. Good enough? You could have rounded this to 3.560. This could have been rounded to 3.259 if you wanted. Another way is on this, you could go to second draw menu, number 5, tangent, type it in x equals 1, and it'll draw it in for you, which is kind of cool. And then they give you the equation right here. So if you follow this equation, guess what you get? Y equals, now they give it to you in slope-intercept form, by the way, 3.258x, which gets 3.258x here, plus 0.301. Okay, and then the other way you could do it is you could go to the home screen to get the derivative, math 8, and derive y vars function y1 comma x comma 1. And that gives you the derivative that we got from the graph screen. So there's a bunch of different ways to do it. So it's up to you. There you go. Find the average value of a function. So this is an idea that we talked about last year. This function, by the way, this is a natural log function, which is y equals 10 to the x flipped across y equals x. But you also have your calculator. So this is what the graph looks like. Right? And we want to know what's its average value from 2. Well, 2 is like somewhere around here to 10. So you're trying to find the average value of this graph, which is the average y value. Okay? So I don't know if you guys remember how we did this. What we did was we said, okay, well, let's take this area and level it out. Okay? Smooth it out. Now, the average of that smoothed out curve is the average height, but then we could use the area to help us. So the area under the smoothed out curve is the same as the area in the original curve. And then now it's a rectangle, so if we divide by the base of the rectangle, we get the average height of the rectangle, right? So that's the way I remember it. So F average is actually mean value theorem, is the area under a graph smoothed out as a rectangle divided by the base of the rectangle. That's it. So I need that set up. You could do this on your calculator if you want. So okay, well, we could graph it. You don't have to graph it, but we could graph it. I think it's good that we had an idea what it looks like first. So we go to window. I say -10 to 11, and then the graph. I don't know. We'll try -10 to 10. See what happens. So I don't know. We could probably see more of the graph up above. That's very nice. So second count, number 7, 2 to 10, shades it, gives you the value 136.39557. Remember, 1 through decimals, plus we're going to divide by 8, so it's probably, let's see, divided by 8 allows you to just divide the answer. 17.049 round truncated comes out the same. So that's one way to do it. You could use the same idea from the home screen and not graph it. Either type in the function or type in y equals, you do 1 over 8 math 9 10 natural log of x, or do vars y vars comma x comma 2 comma 10, and this does it all at once. Same answer, 17.049 round truncated, same answer. So I need at least this setup right here, right? Need at least the setup. Okay. Find the area of the region bounded by the coordinate axis and the tangent line to y equals 1 over x at x equals 2. So I think we need a graph of this. I'm going to try and graph as much of it as I can without the graphing calculator. Not that I'm not going to rely on it, but it's just helpful to know what to expect. So 1 over x is a rational function that has a vertical asymptote x equals 0 because you get division by 0. And it has a horizontal asymptote y equals 0 because as you plug in big x values, the answer gets really small. When it's positive, when you plug positive numbers in, it's here. When it's negative, when you plug in negative values, it's here. And then we want the tangent line at x equals 2, the area bounded by the coordinate axis and the tangent line. So we're actually looking at this area, this triangle right here. So we need to figure out what the equation of the tangent line is, I think. If I plug 2 in here, I get 0.5 for the x value. So, I mean, we could graph this. 1 divided by x. Window. I mean, I don't think I need all this over here, so I could say -1 to maybe 5 would be enough. And then maybe 10 to 10. We just try that. So there it is. I mean, that's probably even more than I need. But we can try that. Now we need to get the equation of the tangent line. So that was just like the problem number 4. So I mean, we do that a few different ways. We could get the slope, the derivative from the graph screen, and say I want it at x equals 2. And it tells us that's the answer. So then we could write the equation and we say y minus 0.5 equals -0.25000001 x minus 2. And then with that, we want to find the y-intercept and the x-intercept. So changing this to slope-intercept form is going to, first of all, show us the y-intercept right away, right? So that value, can we times it? Nope, doesn't let you do that from here. So we could do 0.2500001 times 2. It's going to be positive, right? Plus 0.5. So it's going to be plus 1.0000002. It's pretty much 1, right? And then that's the y-intercept right there, 1.0000002. And then the x-intercept would be when you set this equal to 0. That's how you find x-intercepts for any graph. Okay, so then it'd be that number divided by 0.2500001 and I get 3.99999992. So that's this right here. Now, I mean, you could have found that tangent line other ways and then found these values from it. You could have actually found the tangent line in his equation and used the calculator to find the x-intercept, but I just felt like it was pretty easy to do on paper. But then the way we find this area, you could say, well, let's integrate from 0 to 3.999992 this equation now. And when you put it inside integral, you really do want it in slope intercept, or you do want it solved for y. So you could do this, let the calculator integrate it. Okay, that should give you the answer. Or you'd have to put this equation in the y menu if you're going to do it from the graph screen, but you could do this from the home screen. Or you could say, hey, that's a triangle, 1/2 base times height. The base is the x-intercept, 3.999992, and the height is 1.00000002. And you can find it that way. But I want to see the setup if that's the way you're doing it. So either way we do it. So we could do that times 0.5 times 1.123. So we could do that, and the answer comes out to, the calculus says it's exactly 2. I'm going to write the zeros just because I know there were a lot of decimals involved. So you can do that, or you could, you could integrate it on your home screen. You could say math 9. You could type it in, -0.25000001 plus 1.000002, comma x, comma 0, comma 3.999992. Hey, what do you know? Same answer. So you got some different options. All right, that's it. Be ready for graphing calculator problems.